All right, as we work our way through this area chapter, you've got to constantly be reviewing the formulas and keep them straight in your head. So we started off this chapter with area of a parallelogram. Somebody raise your hand and tell me the formula. Area of a parallelogram. Juliana? Okay, so base times height. So you can just simply answer the question base times height, right? So the area of a parallelogram is base times height. We also did a rectangle. Somebody tell me a formula for area of a rectangle. Chloe? Base times height. Can somebody give me another formula for area of a rectangle? Luke? Length times width. Either way is fine. It's the same thing. The base and the height are also the length and the width. So either formula is fine. All right. How about area of a square? Somebody tell me the area of a square. Christina? Base times height is also a formula for area of a square. Somebody give me another formula for area of a square. Amber? Side squared. There's actually a third formula for area of a square. Nia? Not 4S. Nope. Not 4S. That's perimeter. So far, area of a square we had, what was the first one? Base times height. And the second one was side squared. Okay. Somehow I disconnected on the first one. Yeah, those are the two formulas, right? Base times height. Oh, I know what the third one I'm thinking of. Aaron? Yeah, you can do length times width as well. Is also the area of a square. Okay, so then we progress from there to area of a triangle. We just did homework over area of a triangle, and it was 1/2 base times height. Remember the key. The height is always perpendicular to the base and to the opposite vertex. So make sure you use the correct side of the triangle for the base. Then we got to area of a trapezoid. Area of a trapezoid, 1/2 times the quantity. Base 1 plus base 2 times the height. Remember, the parallel sides are always base 1 and base 2, and the height is always the perpendicular distance between those parallel sides. So you got to know all those formulas, keep track of them, review them as often as you can, and they'll serve you well. Now we're up to area of a circle. So if anybody knows the formula for area of a circle, if you can give me that, raise your hand, give me the formula for area of a circle. Area of a circle. Area of a circle. Area of a broken calculator. Area of a circle. Edward.
Pi or squared?
No, round. Right? Do you agree? You do? Awesome. He said pi r square. I said they're round. You don't see too many square pies, do you? Pi r square? No, pies are round. All right. Yeah, and that is the formula for area of a circle. Pi r, for all you pirates, and squared. And therefore, class r would be the radius. So go ahead and take your circle, draw a radius, and put r there. And so we can find the area of a circle by the formula pi r squared. And remember, your book wants you to, a lot of cases, use 3.14 for the value of pi. I prefer the pi button, but your book is the book, and it's already set, and it tells you to use 3.14. And if you use pi instead, the pi button, then your number will be a little bit off, and I don't want you to be off, so just follow that. That's fine. Get to a quiz and a test, and unless I give direction, I'd take it either way. All right, let's remember a couple things that we already talked about last chapter, and that's the fact that, number one, the diameter, d, equals 2r, right? Double the radius to equal the diameter, or you could think of it this way, half the diameter is the radius. We all know that relationship. That's not a big deal. Somebody raise your hand, give me one of the circumference formulas. One of the circumference formulas. Brendan? Your hand's up. Circumference formula. All right, Allison. 2 pi r is one of the circumference formulas. You can give me the other one. Kristen?
Yeah. D-R, diameter R.
No. Actually, pi d. 2 pi r and pi d. You have to keep track of those because we can give you an area problem where we don't give you the diameter, we don't give you the radius, but we tell you the circumference. If we tell you the circumference, you can figure out the radius. And once you have the radius, you can then do the area. Two-step problem. So don't lose track of circumference equals 2 pi r or circumference equals pi d, okay? Because that can come up as we do some area problems. All right, let's take a look at a couple examples. Most students like area of circle. It's pretty simplistic. So how we start every problem where we're trying to find area, we start with the formula. So to start number 3, we're going to go area of a circle. Again, start with that subscript. Help your brain to be trained that this is the area of a circle. And we're pi r squared. So we're going to sub in 3.14 for pi. And is it pretty clear the radius is 4 meters? It is. So we're going to do 4 meters squared. Again, I like to include my units. It helps me not to forget them when I'm done. It's also good math and it's good science later on when you guys get to science. So take your calculator out. By the way, order of operations, if you were doing it that way, you would deal with the squared part first. Your calculator has to know what it's squaring, so just make sure you know how to punch this in correctly. So go ahead and punch that in. And you should end up with 50.24, and what are my units?
Meters squared.
Meters squared, right, because area is always square units. Hey, now, look, don't do this in your notes, but, you know, this is what we're saying, right? If that was a square meter, you know, we could get 52 of these in there. And look, some of them will stick out, right? And it'll only be the part that's in. But if you were to add it all up, you'd get 50.24 of the square meters, meter by meter squares, right? That would fill up that circle completely. So that's the idea. That's the concept. All right. So when you look at something like B, same way. Area of a circle equals pi r squared. How do we know what that 15 is? How do we know? Luke? How do you know? So are you saying that that's the diameter? How do you know? It is in the center. And that is the designation. And we showed you a diameter line, and we put the number right there at the center points. Now look, if I gave you something like this, and I gave you like an 8 there, then you'd figure out that only this part is the 8. But when we put it in the center, it is definitely the diameter, so be careful. All right, so finish it off. You finish it off at your desk while I finish it off up here. Use your calculator, punch it out. Make sure you know how to punch it into your calculator correctly. Remember, if it ends in a couple decimal places, we'll write the exact value, right? This one ends in 3 decimal places, which is still a round off, but that's okay because we rounded off pi. 176.625 watts. Units squared, right? We do the U for units squared. Everybody okay with 176.625? Right, half of that 15, as Luke earlier said, was 7.5. Pretty simplistic. All right, let's get to the question that is more important than anything we've done so far today. And that is, should I decide to buy a large pizza or a medium pizza? That's the question. That's an important question. Because we're concerned about how much pizza you get on each one, right? And area is how much pizza, right? The larger the area, the more pizza you get to eat. So this is a really important question. All right, to do this, we got to have the formula. Area of a circle equals pi r squared. So for time's sake, all right, for time's sake, Omar, Nathan, and everybody on that side do the 16-inch pizza, and Raph and Luke and everybody on that side do the 18-inch pizza. And let's find out how much area our pizzas are. All right, so who's got a 16-inch answer? Hannah, what do you have? 200.96. Anybody agree? Okay, and that's square inches, right? 200.96 inches squared for the 16-inch pizza. Drum roll, please. All right, let's find out who's got the 18-inch pizza. Amber, what do you got? 254 point what? 34 inches squared. Okay, so watch. What is 1/4 of the 16-inch pizza, roughly? How much area? 1/4 of the 16-inch. 50. And our 18-inch, therefore, has 1/4 or 25% more than that 16-inch pizza. And it's only a 2-inch difference. But we get 25% more pizza. For example, take that 16-inch and cut it into 8 slices. To get a large, you're in effect getting how many more slices? How many more slices? A large is 25% more pizza than a medium. So if you had a medium with 8 slices, a large with medium-sized slices would be those 8 slices plus how many more slices? 2 more, right? 25% more. So that's a little bit of an analogy. So keep that in mind when your parents want to buy a pizza and the large is $14 and the medium is $11. Is that a good deal? Well, Mom, we'll get 25% more pizza if we get the large. Okay, we'll get the large. All right, these days pizza is so inexpensive, it's amazing. Pizza actually went down over time. 20 years ago, you couldn't get a pizza for under like $20. Everybody was charging $20, sometimes more. And now the only places that charge $20 are restaurants. But anyhow, that's another story for another day. Turn the page. D. Just like you guys did last night in solving the base of that trapezoid and the base of that triangle, we can use the area formula to find the radius. Or the diameter. How would you use the area formula to find the diameter? Well, you first find the radius, and what's the diameter in respect to the radius? Twice as big, right? 2 times as big. So really the formula can allow us to find the radius if we know the area, and that's the situation here. Find the radius of a circle if the area is 78.5 meters. How do we always start, class? Formula. So area of a circle equals pi r squared. And let's go ahead and substitute into our formula. So the area is 78.5, and that should be meters squared. Did anybody catch that? Well, how come you didn't say something? You're Kool-Aiding. All right, 78.5 meters squared. Pi is 3.14 times r squared. Does everybody agree so far? Okay. We've already done exponential equations. We've done equations like this. So can somebody raise their hand and tell me the next step in solving this equation? Kristen?
You would divide the 3.14 by the 78.5.
Yeah, we're going to divide both sides by the 3.14 to move that. Again, it's a shortcut. Things multiplied times the variable, we move by multiplying both sides by the reciprocal. Now, quite honestly, don't punch that out yet and write a number down. Leave it just like that. Because every time you punch something in and write what you get, you're writing a round off, and you're getting farther and farther away from the actual answer. So just leave that. Once we have the variable squared isolated, what do we do next? Somebody raise your hand and tell me what's the next step once the variable squared is isolated, which it is right now. It's all by itself. Chloe? Take the square root of both sides. Go ahead and do that in red. You can do it right on there. Do I use the plus minus? Can area be negative? No, you have to be a black hole. So, all right. So area is not negative. So we don't need the plus minus. Otherwise, we would have. So now we're down to radius. What are our units going to be?
Meters.
Meters, right? Square root of meter squared. So do the rest in your calculator. Do the square root of 78.5 divided by 3.14. Again, make sure you take the square on that. I made it nice. This one is nice and even. You get 5 meters. What if you do a problem and you get something like 6.793258747932, Brendan?
Keep the square root.
Nah, we'll round it. If it's okay to go decimal, we'll round. Because usually stuff like this, we just want to get a general idea. So go ahead and punch that in your calculator and round it off to a decimal place, and that'll be fine. But yeah, if we were going to use that, Brendan, a nice exact answer is good to have. So that's a good thought you had. We'll punch that out. All right, last problem. Again, you got to be careful with these shaded problems. Does this problem have a hole? No, there's no hole to deal with. But we do have to come up with a global formula. So area shaded equals, and how does the rest of this formula go? Just give me one part. I want you to just give me a part. Chloe, you're too far down the road. Okay, you're another step down the road. Juliana. Okay, I definitely have an area of a triangle. Hopefully you agree. Again, don't do that on your notes. You don't need to. That right here is area of a triangle, right? What kind of sign do I put next? Say it if you know it. What do I need next? What operation? Add, subtract, multiply, divide. Add. I got to add. Don't those two go together? Okay, I got to add. I got to add to my area of my triangle. What's next? Nah, I don't want the right answer. So put your hands down. Put your hand down, Aaron. Nah, put your hand down, Allison. Come on, give me the answer. I want the wrong answer. Ha! Who's willing to give me the wrong answer? Emily? Bob, no. Come on. What's the next thing? Area of a triangle plus... Emily, what else do we do? What other formula do we need? Area of what? No, area of what? What kind of shape? Area of a circle? Is that correct? It's close. So how do we fix it? Say it if you know it. Yeah, it's half a circle. So we have to do half an area of a circle. Listen, this is how you should start. Don't be so quick to write this specific formula. Write the shape first, and then you can go to the specifics. So our area of our shaded, now be careful. You got to remember the area of a triangle. 1/2 base times height. And we just learned area of a circle is pi r squared. All right, see if you can finish it off. All right, so let me get your attention. Let's see how you did. All right, first off, you better realize that the base of your triangle is 16 meters. How do you know that? You know that this is a radius of 8 centimeters, and this is a radius of 8 centimeters for a total of 16. That should be centimeters, not meters. So how many did that correctly, had 16 centimeters? Right? Makes sense? So if you miss that, you're going to miss it. And then plus 1/2, 3.14 times 8 centimeters squared. My advice is to show each part of these. This front was 80 centimeters squared, and the back was 100 point what? 100.48 centimeters squared. If you're doing a problem like this on a quiz or test, I would show these parts because it's possible to get some partial credit for getting a part of the problem correct. So where do we end up? At 180.48 centimeters squared. How many got that correct? Okay. And again, if you miss the 16, you're going to get it wrong. You're going to be off by 40 centimeters squared. Question, Daniel.
I don't understand how you got 16.
Okay, let me do it one more time for you. So let's even get rid of that bottom there. Daniel, you agree that the radius right here is 8 centimeters, correct? Let's keep moving this way. Therefore, from here to here is how much? 8 centimeters. Let's go the opposite direction. Keep moving. Keep moving. When we get to here, how much is from here to here? 8 plus 8 is 16. Isn't this the base of the triangle? And isn't this the height, the two sides that meet at the right angle? So base of 16 centimeters, height of 10 centimeters. Okay. Any other questions? Anybody else? All right. So area of a circle, not too bad. Pi r squared. You got a good 10 minutes left. Let's get started on our homework. Quiz tomorrow, right? Quiz tomorrow.